Hello, welcome to this chemistry tutorial. I am Benjamin. In today's episode, we're going to study gas laws. Specifically, we want to start with Boyle's Law. Boyle's Law states that the volume of a given mass of gas varies inversely as the pressure, provided that the temperature remains constant. This law was propounded by Robert Hooke in 1662. It shows the relationship between the volume of a gas and its pressure. According to Boyle's law, the volume of a gas increases as the pressure decreases, and vice versa. Mathematically, the law can be expressed as V inversely proportional to P. That this V stands for volume and the P stands for pressure. This shows that when volume is increasing, pressure is decreasing, or when pressure is increasing, volume is decreasing. Let us see the mathematical constant of this law. If V is inversely proportional to P, mathematically, you remove the proportional sign and introduce an equal sign with a constant. This will multiply by 1 over P to give us V will be equals to K over P. K is a constant here. Now, making K the subject of the formula, we have K will be equals to PV. Now, this law can also be restated as the pressure of a given mass of gas varies inversely as the volume, provided that the temperature remains constant. Now, in that case, we say that P varies inversely as V, and removing the proportional sign, we have P will be equals to K times 1 over V. This will give us P will be equals to K over V. And P will be making K the subject of the formula. We have that K will be equals to PV. That is to show that there is a relationship between the volume and the pressure of a gas. When the volume is increasing, the pressure decreases. And when the volume is decreasing, the pressure will increase. That is how it is. Now let's look at the graphical approach of this law. Now, when you are given a question to tackle in your examination, you will observe that there is no temperature in the formula. You can see, as you can see, that V is equals to is directly proportional to 1 over P. That means temperature is kept constant. It's not appearing in the equation. So whenever you see that temperature is not appearing, you must understand that it is Boyle's law, because Boyle's law entities, which is the volume and the pressure. Now, graphically, we have a straight line graph from the origin, having the y-axis is the volume, and then the x-axis is the decrease in pressure. And then you have a graph from the origin. Then looking at the second graph there, the second graph talks about the pressure increasing. This is increase in pressure, and this is decrease in volume. This is anyhow they tell it. You must understand that there is a relationship between the pressure and the volume of the gas. And so there is when there is increase in pressure, there will be decrease in volume. And when there is increase in volume, there will be decrease in pressure. Diagrammatically, let us see how we can practicalize the law. Now, if you look at this diagram, you see that this is a beaker A. We have beaker A, beaker B, and we have beaker C. Now, in beaker A here, we have 3 masses. Let's assume that one mass is 1 mass is equals to 1 gram. And we have 3 grams masses on this volume. Let's call this volume, let's say this is V1. Now, the volume V1 is at this point. Supposing that this point is about 200 cm cube. This is 200 cm cube at this. Now let's go to beaker B. In beaker B, we increase the masses to 5. And now you can see that immediately we increase the masses. This mass represents the pressure. This equals to the pressure. The force that is acting on the volume is the pressure. Now we increase the pressure. The volume here decreases to V2. And let's say this V2 is about 150 cm cube. And now in beaker C, we further increase the pressure by increasing the mass. That leads to increase in P, and this increase in the P leads to the formation of the volume 3, which is V3, and that is to say the volume decreased to, let me say, 50 cm cube. So you observe that the more we increase the masses, the pressure is increased because the force is increasing, and that force that is increasing leads to the reduction in the volume. So in this case, we have V1, and we have V2, and we have V3. Supposing that each increase in pressure leads to a corresponding increase in volume, we are going to have that P1 V1 is equals to P2 V2. This is your formula for calculating either the volume or the pressure in Boyle's law. Also, let us consider these two pipes, say pipe A and pipe B. Now you can see that the volume in this pipe is very small. The volume is very small, the diameter is small, but let's look at it as volume. It's very small. Now in this case, the pressure, the force that is acting inside this pipe will be very, very high. Now, if we are passing water through this pipe, you see that there will be increase in the pressure, and so the water volume that is coming out will be very, very high. But considering pipe B, the volume here is increased. The volume is larger than pipe A. You see that here the pressure, the force that is going here will be lesser. So there is decrease in pressure. So in summary, Boyle's law states that when the volume of a given mass of a gas is increasing, the pressure will be decreasing, and vice versa. In it also, you have to note that there is no temperature, because temperature is kept constant. Whenever a particular problem is given to you and you see that there is temperature, please don't go to use the formula for Boyle's law, because you're not going to get it right. But when there is only pressure and volume, we say that volume pressure law is the Boyle's law. And the formula you are going to apply, remember, to solve such problem is that P1 V1 is equals to P2 V2. Thank you very much for watching. Please subscribe to our channel for more videos. You can watch the part 2 of this Boyle's law, which will involve calculation in this law. Thank you. Goodbye.